Now welcome to the seventh lecture of the C++ program. Okay, in the previous lecture we have talked about the standard template library, right? What are the templates? What is standard template library and virtual function? And before that we have already covered some important topics like that of inheritance and polymorphism. Okay, so if you have missed all those, I would recommend you to go back and clear those concepts first and then continue from here. Okay, so this is Yashivasa. Let us start today's lecture. Okay, so first of all we should talk about this one more topic, that is generic programming. Okay, so I should have talked about it earlier, but okay, it is not that important topic as that of the previous one, so I decided to give them more attention. So let us complete this topic also over here, that generic programming. So the drawbacks of qsort in stdlib.h. Okay, I told you that it is a package that is that is included in the beginning of any code when we write, right? So this include stdlib is a library package that we install before writing the code. Okay, many others are there, but for now in this case we are going to talk about this. So what are the drawbacks of it are written over here, that requires a compare function. Okay, it always requires a compare function even if it is trivial. Okay, even if it is trivial, still it requires a compare function. Okay, so that is the first drawback. And second is loss of efficiency. Okay, if you are going to use this, then you will lose. Like, it is not like, I would like to say that it is, this package is not always having drawback, but for the case of qsort. Okay, what if we are talking specifically about the qsort over here? Okay, and the loss of efficiency because dereferencing pointer. Okay, why it happens? It is because of the dereferencing pointer. Okay, I told you what is the referencing and dereferencing pointer and what is the pointer itself in detail in the previous lectures. So better go and read this topic if you have missed, and if not, then you might be understanding all these things very easily. So loss of efficiency is the second bad drawback, and the third is loss type safety because of void. Okay, void is again void pointer it is written. Okay, void pointer, because what I told you that void is just empty. Okay, and if you are pointing towards that, you are giving some reference of that, it is just null, right? So loss type safety. Then other thing is only works with contiguous array. Okay, so if you don't have contiguous array, it is not going to work out for you. Okay, in the case of qsort in stdlib.h. Okay, what we say, call it as standard library.h. Now, no control over the construction. Okay, we don't. This function doesn't have any control over the construction, destruction, or assignment. Right? All these things are very important. What is construction and destruction and assignment? I told you in detail in the previous lecture. So we basically don't have any control over it, and we are going to use it. And all swapping done by raw memory moves. Okay, all the swapping will be done by only the raw memory moves. So these are the major drawbacks of qsort in stdlib.h. Okay, so whenever we are using it, we should avoid this qsort, right? Then iterators. Okay, iterators are nothing but the generalized pointers. Okay, that too is written over here. Okay, each container has its own type of iterator. Okay, every different container can have its own type of iterator. Then this is a void function, and inside that what we are using, stl vector of type integer, and what variable we are using over here, it is v, and then stl, then again we are using over here vector, then type integer, then what we are doing over here, we are putting two semicolons, then constant iterator. Okay, iterator means how many times basically the function has been run. Okay, that is what iteration is, and the function which helps in it is the iterator. Okay, iterator it, it is a name which is equal to v. Okay, and then for all the iterator v begins, or if the iterator is not equal to the v end, we are continuously going to increase the value of this it iterator. And what we are going to do after every loop, we are going to print integer value of val that is nothing but a pointer to it. Okay, so how many times we are going to repeat this process, or how many steps involved in it, that will be called as the iteration, and the function involved in that is used for it, that is called as the iterators. I hope this is clear to you. Now see, types of iterator, that is one thing more we need to discuss. That template, okay, template you all know, and in the previous slide STL also you know. Then class input iterator, okay, what we are going to do, we are giving input iterator, and then class type, okay, class as type, okay, then input iterator find, what we are going to use it as input iterator find input iterator first, okay, here also should be a okay, we cannot separate these words, otherwise they will act as different things, okay. Some yeah, misprint is over here. Input iterator underscore first, output iterator underscore last, okay. Then const, what we are declaring as const, that is nothing but and type value, okay. What I told you, this is just a reference, okay. So each container provides a different type. By this example, we are just trying to say that each container provides a different type. So see over here, there are two types, input and output, okay. So this random access is having access to this bidirectional, and then it is a kind of forward type, okay. And then forward is nothing but an input type, okay. So therefore we were talking about these type in the iterators. So there are two, input and output, and inside this input there is forward, and inside that forward there is bidirectional. Bidirectional, you itself from the word you can get the meaning that it has access on the both sides, bidirectional, two directional, okay. And then random access. We have talked about the random access in the previous slide also, right? Okay, I hope till here it might be clear to you. And now let us move on to the next topic, that is allocators, okay. This is also a very important topic in C++ programming. STL written for a maximum flexibility, okay. Even when we were discussing about the templates, the STL, then also we were talking about the allocators. So STL written for maximum flexibility, okay. So STL is written for maximum flexibility, okay. That's why we are using templates, and each container has an allocator, okay. In the previous slide, we were looking at each container has a its own iterator type, and now what we are reading that each container has an allocator, and allocator is basically responsible for memory management, okay. Now see, what is written over here, new or delete. Suppose if we talk about a general English word, allocator, okay, what will you think? It is it is a person which is allocating something, when something to the people whoever come to us, right? Suppose there is a person like that of warden, okay, who is allocating a room to all the students, then that can be called as allocator, okay. Basically something which is allocating whatever thing it can allocate, okay. But for here what we are talking about, in this case it is responsible for memory management, okay. What it is going to do, it is going to allocate something new to the function, and if it is not required, it is going to delete, okay. So suppose someone new came to the college, it is going to allocate the room, and someone passed out, it is going to delete it. That is what the basic function of allocator, right? So what is written over here, it is just a pseudocode kind of thing given over here, that template inside that class type, and what we are making a different class for allocator, and here we are writing the function for allocator, that allocator type, and then we are continuing the other code, that is class vector and remaining things. But here is the main use of what allocators are, okay. here is the actual pseudocode written about the allocators, and at the end, a general advice is given to you that we have to just simply ignore the allocators. Okay, we will be using it, but it is just for the case of memory management. Okay, so we can ignore allocators. Okay, now I hope till here all the things are clear to you. Okay, allocators, polymorphism, inheritance, standard template library. Okay, and so many other things we have discussed in the previous lectures. Okay, so I request you to kindly cover all the topics if you have missed any one of them. Okay, and yeah, this is the end of this today's lecture.